serial jobs. And we'll see some examples. There's a Java universe, which is very helpful if you happen to write your program in Java. Probably not many scientific engineering types are writing in their programs in Java. Is that true? Anybody write in Java? Okay. There's a universe for parallel jobs. There's a universe for virtual machine jobs. So in Unix, right, everything is a file. Right, and they get all kinds of power from, it's abstracted away. It's /proc. You find out what's going on in the memory of a process by files. Right, everything's a file. In Condor, pretty much everything's a job. Right, so virtual machines starting up, yeah, that's a job. And why is that nice? For instance, I mentioned Condor supports interdependencies between jobs and data migration between jobs and all this stuff. Well, if virtual machine instances are just jobs, now you can have interdependencies between how virtual machines start and when they start and all that kind of stuff. It's pretty neat. Okay, so first example, we'll use the vanilla universe. So this is essentially a serial job. Provides automatic movement of your files back and forth if you want it. And like vanilla ice cream, can be used in just about any situation. So, it could be a program you write. It could be a commercial application. It could be, I don't care, ANSYS, Mentor Graphics. I don't know what you guys use a lot here. Anybody have something they run all the time? Not really?
Stuff I wrote.
Stuff you wrote. There you go. So the next step before you submit your job is obviously you make your job batch ready. For most programs, especially scientific type apps that like read a bunch of files and do a bunch of stuff, you redirect the output to standard out and error to a file, redirect keyboard from standard in from a file. You don't want a job that pops up GUIs, this and that. Yeah, no music. That's a good, that's a good one. So an early cluster we had at Computer Science was called the COW, the Cluster of Workstations. And a test program they had for it did a little moo out of every little machine, so you would go. So you make your job batch ready. We talked about that. You create a submit description file. The submit description file is simply an ASCII file that basically tells Condor what to do, and you stick in there what executable to run, any command line arguments, environment variables, this and that. You can describe many jobs at once, and hit enter and submit 10,000 jobs at a swing. We'll talk about that. So here's a really simple submit description file. The universe is vanilla. Here's my executable, and here's some output. All you do is you give that to Condor Submit, do Condor Submit space name of that file, hit enter, and you're done. When you run Condor Submit, it throws the job in the queue. So we talked a bit about Condor matchmaking, and just to formalize a bit, what is it matching? Condor is matching what we call class adds, and classified adds is a language that was developed in the Condor project, and it's a language for resources to describe themselves and to describe what they're looking for in a match. Single white male, looking for blah, da, 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 so it works very much like the name implies. So class adds have attributes about themselves. They have, like I said, they have a requirements and a preferences, and this, the requirements and preferences is basically to describe what they're looking for in a match. I'm a job looking for a machine. I require it to be Linux. I prefer it to have a lot of RAM. They're semi-structured, schema-free, yada yada yada. There's a lot of research papers about the wonders of this language. I could talk about it more, or we could, or people could ask questions. But here's an example. So this is an example of a job class add. So I'm a job, I'm looking for a machine. I was submitted by this guy. When I want to run this executable, and I require a Linux machine that has more disk than I'm going to use and more memory than I require. Essentially, is what that expression says. So class adds support strings and numbers and Boolean logic expressions. So the Boolean logic expressions are a lot like C C or Java notation, right? And the beauty of these expressions is they can reference any attribute that's in things that you're trying to match with, right? So machine class adds are all advertising what their architecture is, what their operating system is, how much disk and how much memory they got. And in fact, out of the box, Condor advertises about 80 attributes about each machine, about 80 attributes about each job, and so, there's a lot you can do. Furthermore, the attributes can be added to. It's easy in the, when you install Condor, you can add custom attributes to machines or jobs. These can be static attributes or dynamic attributes. You could even add an attribute into a machine class add that says who's logged in at the time. That would be an example of a dynamic attribute. I want to run on machines where my friend I like to poke is always running, right? And my job is going to, log keyboard activity. I don't know. It's good fun. I know at CAE a while back there was all kinds of crazy attributes that were static that had to do with what lab the machine is located in, what time this lab is locked at night so nobody's in there, and jobs that were unable to be checkpointed and migrated would be steered towards labs that were locked, right? So that the machines that, so they could run uninterrupted, all kinds of good stuff. So when you run Condor submit, it basically took that ASCII file, creates a class add representation of it, submits it to the scheduler process in Condor called the schedD, and in the details, this is something else your Perl script would have to deal with correctly, but it's an atomic operation, kind of like a database. It's impossible when you're submitting thousands and thousands of jobs. Murphy's Law is going to bite you. You don't want to ever end up with a job that's half submitted. The executable is bin su, but the arguments were -c, this program. So, it's half submitted, bin su just runs, who knows, right? You don't want half submitted stuff. And you view the queue with the command line tool, Condor queue. So Frida runs Condor submit, then she runs Condor queue, and Condor gives a very pithy output about, well, here's your job that's submitted. And there's a couple pieces of information, like how long it's run and the status. And here I means the job is idle. So there's a bunch of other stuff you can put in this job submit description file. Standard in, standard out, standard error. That's pretty straightforward. You can tell Condor to notify you when your job completes, or if your job has an error, it can notify you with email. There's a trillion. The Condor manual is like 1,100 pages long, and most of that is not needed by everyone, right? But kind of like Microsoft Office or something, there's some feature that's needed by someone somewhere. So in addition to notifying via email, there's a lot of ways you can get notified. Let's just leave it at that. In fact, some people have their instant messenger service, and Condor starts sending out instant messenger. You can start talking back to Condor too about what you want it to do. Oh. That was a little. You can also just ask Condor to keep a log of everything it does with your job. You just put in your submit description file, log equals some file, and that's kind of the life story of your job. It can, be written in XML format or this or that, however you want. But it's kind of nice because it just writes a simple event every time Condor does something with your job. Here's an example of what a snippet would look like. Oh, you submitted it at this time on this machine. Oh, it started running on this host. Oh, it terminated, running on this machine. This was the exit status, a bunch of stuff. Maybe you want another program to read that. So here's another submit description file. Has a little more stuff in it. Initial dir is just what current working directory it should start in. Job IDs have two parts. There's a cluster and a proc part, we call. So the first number is a group. It represents a group of jobs, and then every job that's submitted in the same Condor submit command gets a .0, then .1, then .2.